to do, let's just move all of this information to a new page. There we go. Okay, and let's take a look at this. Let's see if we can't figure out why this works. You know, in mathematics, there's so much stuff. And you started this when you were in probably first grade. There's so much stuff that we tend to memorize, and it depends on how it's presented to us. And sometimes it's presented with what we call trust me math. Trust me, we just do it this way. Trust me, this is just the formula we use. And I don't know about you, but there are many times that I would think, well, why? Why does that work that way? What's the big deal? Why would I want to go about in that direction? And so I don't want the math that we finish up on to be trust me math. I wanted you to have some meaning for it. By the way, have I told you 10 years from now what I want to be able to do? You know, meet you on the street and ask you. I now can ask you two important questions. One, what's a derivative? And what answer do you think would suffice? The slope of the line tangent to the derivative point. We spent all semester doing this. You know, and 10 years from now, if we don't remember that much of this course, man, we just kind of wasted a whole semester. The second most important question is, well, what's an integral? Geometrically speaking, what's an integral? And I would hope that you would know that it's the area under a curve. And you find it by just looking at areas of rectangles. So when you think about those two basic questions and then looking at this formula here and thinking, well, okay, trust me, it works, I want you to have more than just a trust me on this. So let's go back and let's just talk about this. Oops. What does, if I can just get that, there we go. What does this represent? We just talked about it. That much of it represents area. Area under a curve. Okay. So when we talk about area, area is you know, the formula for area is what? Base times height. Okay? So when it's base times height, what does this represent? If this is area here, this much is base, width, okay? The base or the width. So now if you take area equals base times height, and this is really 1 divided by the base. So if I divide both sides by the base, what do I have? Height. And how do we define the height for these rectangles? Yeah, f of some value c within the interval a to b. Okay? So that really is not a mystery to us. It's very basically take what you know, area, divide by what you know is base, and what do you have? It's kind of like when we get into problems with distance, rate, and time. We sometimes will say distance divided by rate is time, and so we're given distance and rate, and we're asked to find time. So, you know, it's the same thing. We're just taking a very old, familiar formula and dividing by the base. Okay. This height that we get here then is whoops, I will go down, we'll do that again over here, is known as, you know, f of x. We'll make it f of c up there. Okay, so with that in mind, let's look at this example over here. It says, find the average value of this function over this interval, and all the values of the input in the interval for which the function equals its average value. Find the average value, and again, I suggest, when you see average value of the function, say average value of the outputs. Okay, the average output value of the function. And we do that. So average output of f of x is the same thing as 1 divided by b minus a, and then the integration from b to a of f of x dx. Can you find 1 divided by b minus a? Yeah, that's a simple. Sure you can. Yeah, it's a simple question. We know that. Can you find this value? Yeah. Can you multiply them together? Sure. Okay, so, we've got, what is that, 1 divided by 2, and this is the integration of 1 to 3 of, now again, we're still in pre-5.5, so if we're going to take a look at this, we might want to make it 4x squared plus 4 divided by x squared, so that's going to be 4 plus 4 divided by x squared, or 4 times x to the negative 2 power. So I'm going to put that in here, 4 plus 4x to the negative 2 dx. And so I'm going to have 1/2 times, and I trust that you can do these integrations, some of you maybe in your head. What I want to see on that final quiz is some work, and I may get one problem where I say, show me the steps, just to prove to me that you're not just going to the Inspire and putting it in, that you actually know how to do this. But I think, for most of you, we're past having to write the exponent of plus 1 divided by that, okay? Plus, this one's going to be what, though? Add 1 to the exponent back in, and we get what? And then divide by that, and so we end up with negative 4x to the negative 1, okay? Integrating from 1 to 3. So we've got 1/2. Now, what I would do with this problem is I would keep that 1/2 outside of everything. I wouldn't mix it in, just kind of keep it out there. And inside here, I would put f of, the antiderivative of 3 minus the antiderivative of 1. You can do what you want with that. Everyone has their own personal preference. Whatever you do, make sure you show me your work, is all I ask. So I'm going to do that. And let's see, I'm going to have 4 times 3 minus 4 divided by 3 minus 4 times 1 minus 4 divided by 1. And we've got 12 minus 4/3. What happens inside here? It cancels out, yeah. So I'm not going to bother with, I could say minus 0 if you want to see that. Okay, so let's see, I've got 1/2. Well, let's see if we can do better than that. We're going to have, what, 6 minus 2/3, which makes it 5 1/3. Which makes it 16/3. Okay, 16/3. What have we just found? So easy to lose sight of what we're doing. We found a nice answer. Big deal. So what? What does this represent? It's a height, okay, but it's also the average output value of f of x. of all the output values between input of 1 and input of 3, if you took all those output values and you added them up, could you add up all those output values? How many output values would there be between input 1 and input 3? Infinitely many. You can't add them all up, okay? You can add up maybe 1,000 and do it by hand and all that stuff. You don't want to do that, you know. But this is your average output value. Okay, now, we're not done though, because it says, and find all values of input in the interval between 1 and 3 for which the function equals this. How are we going to do that? We just found what? An input or an output? An output, okay? So an output has value. This has to equal that output value. Finding your way through that now? Okay, so step B would be to say 16/3, that's an output value, has the same value as this output. Oops, that's a 4. Let's make that correct. So let's see, I've got 16 x squared equals 3 times 4, 12 x squared plus 12. 4 times 3 is 12. Multiply that through. So I have 4x squared equals 12. I have x squared equals 3. X has what values? Okay, so there are 2 values, right, of the input that yield that output. Caution. One of them, yeah, one of them is not in that interval. So we have to be then in the interval from 1 to 3, and so only x equaling the square root of 3 is in that interval. What's it look like graphically? Let's take a moment to look at that. Yeah, Becca? 16 divided by 3, where'd that come from? Okay, because what we've been doing in the top part of this, you know, the first part is that, the second part is here, so you know, we're finding the average value, so the average output value. Now, does that say that, is this saying that there is a point that has that output value? Whoa, wait a minute. What did we just find?
Will there always be a point though?
If it's continuous, okay, if it's continuous, the answer would have to be yes on that.
At least one.
Yes, yes, at least one. Okay, so let's take the inspires, and I'm just going to add a new page, and put in our function. Let's see, that is a fraction, and it's 4 times x squared plus 1 divided by x squared. Change the window. You know, and some of you, I think, still kind of struggle with the window. You know, with these, it's pretty easy. You got an interval, right? You just got to make sure I see that interval, and make sure that I always like to see the origin. Kind of gives us a point of reference here. So make sure we have that. And we see some of this up here. So, you know, if I keep the maximum output value where it is, you know, I may make it 6 or 7 or something. I don't need to see much down here. I mean, choosing the window is not that difficult. Now, I do realize that there is a window for just the first quadrant, but then it puts it right at 0. And so, as I do, I always like to see the origin. Most of you are, you know, I give you the window and you're pretty happy with it. Sometimes we make some changes. So what we have, it's from 1 to 3, so I'll make it 1 to 4. Scale by 1. And -1 to, I'll make it 7, scale by 1. So between 1 and 3, I've got infinitely many